So my name is Joseph Cotter from Imperial College London, and I lead the project Quantum Sensing on the London Underground. GPS is this incredible system that enables us to position ourselves very accurately pretty much anywhere on Earth. But unfortunately, GPS doesn't work underground or underwater. And so in those kind of environments, it's useful to have alternative navigation systems. So one way to avoid having to use GPS is to use inertial navigation. For that, we measure the acceleration and rotation of a platform, do some maths to figure out how the vehicle that we're looking to navigate has moved in some map frame. And so that's the principle behind the Quantum Sensing on the London Underground project. We want to see if we can use quantum sensors to improve inertial navigation for underground railway positioning. So what the funding has enabled us to do is to work closely with TfL and explore opportunities to commercialise this kind of technology in the future.
So here we're testing on a train. Classical sensors, one of their issues is that over long periods of time they'll drift, but by hybridising it with a quantum sensor you should be able to remove that. We're using atoms to try and measure the acceleration of the train. So we have to cool them to very low temperatures by using a combination of magnetic fields and light. And then we use a process called atom interferometry to actually measure the acceleration.
In future, using the train as a sensor is the direction that most railway operators in the world would like to go to. Quantum self-contained, it's not reliant on GPS, which the UK doesn't own. GPS can't be used as a safety-critical mechanism to authorise train movements. If we develop technology of the quantum sensing, then it has the potential to change how we look at signalling going forward. Other benefits of improved signalling and positioning is that we'd be able to understand our track condition.
GPS does not work particularly well in our tunnels. So if we have a more precise, accurate way of measuring where we are, we can identify, diagnose, predict failures better, more precisely. So if we fix the problem more quickly, we have less downtime for our passengers, and that gives us a safer, more reliable, more efficient railway.
We are only a small part of infrastructure that operates train services daily. Network Rail and the rest of the world could adopt this technology, so scaling it could lead to significant savings of carbon and also time and money.
It is exciting. I mean, it's nice to see quantum sensors go from the lab to the real world, and I think that there's a genuine opportunity to deliver some sort of societal impact through this research.
The technology is new. It will not be ready today, tomorrow, next year, but in the future this could change the landscape of how railways are operated throughout the world.